Hey guys, welcome back to day 9 of SAT ACT Math. Today we'll be tackling problems 13, 14, and 15 from SAT Practice Test 10. It's the official College Board one. These are not my problems, but I'm just doing these so I can give some people something, so I can help some people out with these. SAT is coming up soon. The August one is coming up soon, and I think that might be your last chance to up your score. So I'm just hoping I can help a couple more people out, get a better score, and get into a couple better schools. Okay, without further ado, let's get started. One thing I will say is that 13 and 14 are paired. So when you're doing these, if you do it backwards, some people like to go backwards to get the harder problems out of the way. I do that for the ACT. That's how I got my 35 for the ACT. But I don't like doing that for the SAT. I just go in order for the SAT, and it did work. I got a 790 math, and I think going in the right way is probably better for the SAT since the problems don't get as hard as quickly, and they don't get as hard in general. The ACT math I'd say is harder, but without further ado, let's get started. Okay. First, always read the problem. 3 colonies of insects were each treated with a different pesticides over 8-week period, right? So colony A gets pesticide A, colony B gets pesticide B, and colony C gets pesticide C. That's exactly what it says after that, right? Each pesticide was applied every 2 weeks to one of the 3 colonies over the 8-week period. The bar graph above shows the insect counts for each of the 3 colonies 0, 2, 4, 6, and 8 after the initial treatment. Okay, let's just get started. Which of the following colonies had showed a decrease in size every 2 weeks after the initial treatment? And the keyword is every. Okay, it can't just be once, or it can't be like it can't be like all the time except for once. Every time. Okay, colony A. Okay, 80 goes to 80 to less than 60 to less than 40 to less than around 30, and then to like a little bit less than 20. Colony B is a little bit harder to tell, especially with week 4 and week 6, but you can kind of make it out. Week 6 is definitely lower than week 4. Colony C is not. It's doing its own thing. I mean, it does reduce after week 2, but like 0 to 2, that's not. It goes up from 0 to 2. That's not an increase every week. And keyword is every. So colony A, colony B. I like check marking like here to make it a little bit easier when I'm circling these. So 1 and 2 should be choice C. Move on. Of the following, which is close to the ratio of total number of insects in all 3 colonies in week 8 to the total number of insects at the time of the initial treatments? So it should be initial to final. Okay, your initial is it should be final to initial. Final to initial. That's your ratio. All right, so total number is okay. So it's around 50 here, around 20 here, and around 10. No need to be exact. I mean, you should be exact, but it's not exactly 20. It's not exactly 10, but we'll call it that. So it's 80 final. Okay, and then you want to count at the beginning. Okay, so this one's 80. This one's a little bit more than 60. This one's a little bit less than 60. We'll call them both 60 just to make our life a little bit easier. That equals 200. So the ratio is 80 to 200. Okay. First, just cancel out your zeros. 8 to 20. 8 to 20. That's not 1/2. That's not 1/4. Okay. You can get those out of the way real quick. And then they're both each divisible by 4. Okay. So then you get 2 to 5. And that's one of your answer choices. A. That's how you do that one. Move on. Okay. For this one, you need to know the volume of a right cylindrical cone. The right cylindrical cone, circular cone, sorry, it's 1/3 pi r squared times height. Okay. The volume is 24 pi. Okay. Equals 1/3 pi r squared times height. With that, plug into it. Says that if the height of the cone is 2 inches. 2 inches. Okay, so 24. You can cancel out the pi's immediately. And then also I would take out the 2's. So I would divide both sides by 2. So um, 20, 24 equals 1/3 r squared times 2. Divide both sides by 2. And then you get 12 equals 1/3 r squared. multiply both sides by 3 to get rid of this 1/3, right? So multiply by 3. You get 36 equals r squared. Take the square root of both sides. R equals 6. Okay, and that's one of the answer choices. You got to be careful on this one. It's a right circular cone, not a right circular cylinder. Here's the cylinder, and then like here's a cone. Forgive my like abysmal drawing. That's a cone. Let me draw you a little bit better cylinder. There's a better cylinder. Let me get this one out of here. So cone, cylinder. You get the point. Cylinder. Okay, with that, that's everything today. Oh yeah, let me just give you the volume of a cone. I mean a cylinder. See, even I mess it up. It's pi r squared times height, not 1/3. That's the formula for that. If it asked for like a right cylindrical cylinder, that's how you do it. Yeah. Okay. That's everything. If you enjoyed this video, please give a sub to the channel and like. That's all for today. Please come back tomorrow for day 10, where we'll tackle a couple more problems. No calculators needed for this. If you want for 14, you could use a calculator for 14, just to be sure. I would suggest using a calculator when you can. Use a calculator for 14. You don't need it for the other ones. All right, guys, see ya.